Howdy and welcome back. So let's introduce an actual inheritance scheme in C++. So visibility of inheritance, this will be the different modes of inheritance available to us within the C++ programming language. So we need a base class first, right? We need something to inherit from. And this is, it's going to be nonsensible. There's going to be 3 data members with different visibility. So for instance, here we'll see in truck, and again, this isn't doing anything truck related. It's to illustrate what happens to the data members or behaviors. So what we were saying for X, Y, and Z, these data members here is going to hold for behaviors as well. So for function members. But anyways, public is something y'all should be familiar with by now. And this is going to be where we'll have this variable X declared, this data member X, which means it's going to be accessible by both functions defined within the scope of our class, as well as to any users of our class. There will be direct access to X. Protected will have a integer variable identified by Y here. Protected means that it's only going to be available within the scope of the class. So users won't be able to use it. And in addition to this, protected is going to add on the following, that the members that are inheriting from our base class will also have direct access to Y. So it's protected's kind of like only people within the family of truck will have direct access to Y in this case. Otherwise, people who are using our class will not have that direct access. And we'll see here, this is, I don't like using protected data members because, and I'll try to set this up in a later video, but the idea would be, I kind of want the base class to take care of everything related to the base and the derived class to be focused on the derived portion and not mix those by essentially allowing the derived objects to directly access Y, which is going to be allowed in this case. But let's kind of continue on. We'll get there. I don't want to get too far ahead of myself. So private, we'll have an integer object identified by Z here. Z is only going to be accessible by functions, by member functions scoped within our truck class. So users won't be able to access it. And you've seen this before. If you've, create truck and then write truck.z, compiler will give you a nice little error message that says, hey, that's private. You can't access it directly. Instead, the only functions that can are those that are going to be prefixed or belong to truck. Some function, descriptive name. Okay, derived types from this base will not be able to interact directly with Z either. It's private, only truck is going to be able to interact with it. So in an inheritance scheme, if you wanted to interact with Z, you'd have to essentially do so through one of the functions that were declared either under the public or protected access specifier. And we'll see here, I guess, just one more thing. So I mentioned I don't like putting data members under here, but I never said anything about member functions. That could prove to be very productive in this process of allowing us to interact with, say, private data members, but not allowing users of our class to do so. So visibility of inheritance. First one we're going to talk about is going to be public. So this is going to be the traditional style of inheritance, and it's going to be used to model an is-a relationship. So we might have a fire truck is a truck, a concrete truck is a truck, a student is a person, a faculty member is a university employee, etc. There's a bunch of different relationships that we can represent within our programs. And public inheritance would be used to model an is-a relationship. So if we want to say that fire truck is going to inherit the attributes and behaviors of truck, that is, fire truck is a truck, we do the following. Now, here's what you've seen before, our class declaration saying, hey, we're introducing a new type. It's called fire truck. Now we see this colon followed by the mode of inheritance, followed by the type that we're inheriting from, in this case, truck. type inheriting from. So in this case, fire truck is going to inherit from truck with public visibility. Now, I have in this, if truck and fire truck are known, then it is also known that fire truck inherits from truck. So in other words, a fire truck knows who its parent is, and we'll see kind of the implications of this. So in this case, remember our data members here, X, Y, Z. X was public, Y was protected, Z was private. In public inheritance, all of that is going to stay the same. X would stay public. So if we had a fire truck, say fire truck, let me use a different color. If we had fire truck, FT, we could write FT.X because X was public in the base class. We're going to inherit it using public visibility, which means X will stay public within our fire truck. Y likewise will stay protected and Z is going to stay private, meaning we won't be able to directly access Z within functions scoped to our fire truck. So fire truck functions will not have direct access to the base class's private data members. And this is important to keep in mind. And you might go, well, how do I interact with, say, those data members? Well, you might have inherited some behaviors publicly from the base class type that would allow you to interact with the private data members. And if you think about this, one of the reasons why is there might be some invariance placed upon those data members of the base class that are enforced by, say, the public or protected methods. So restricting access to Z through those methods will ensure that that variant is maintained through the lifetime of, say, our fire truck objects. So that is, avoiding unrestricted access to the data members can be very productive. So here's just, setting it up in a bit more, kind of tabular form to help lay out how things are structured. So in this case, we have truck over here. Let me just highlight that. So you all know I like doodling, so I'm going to doodle a little. So there's our truck. And then over here, here's our fire truck, which is going to be inherit from truck. So again, notice here that X is going to stay public, Y is going to stay protected. So that means that in the subclass, so fire truck, we'd be able to directly interact with Y, because again, the visibility of Y is such that function scope to truck or function scope to its children, such as fire truck, have direct access, but the outside world does not. And then let's, use a light blue. Z is not going to be directly accessible through fire truck. Okay, so the next mode is going to be protected inheritance. And this is where things are going to start to get interesting. We're going to shift away from this idea of representing an is-a relationships towards a protected implemented in terms of relationship. I'm going to go through this slide fast, and I'll spend a bit more time on private inheritance, which is going to have a similar kind of idea. But if we say class fire truck, it's inheriting using the protected mode from truck. The inheritance here is going to be a protected scheme. Only fire truck and fire truck's children are going to be aware that they inherit from truck, which means we're not going to have an implicit conversion necessarily where we can cast, say, coerce, or even, explicitly cast a object of fire truck to, say, truck. So what's going to happen here is that X is going to become protected. So the whole idea with this kind of scheme here is going to be that the outside world is no longer going to have access to the public functionality afforded by the base class. Instead, we're going to restrict that functionality within the scope of fire truck. So in this case, X is directly accessible only within the scope of fire truck, or because it's protected, fire truck's children. Y is going to be, so we'll have direct access to X, it's just our users won't. Y is going to be as described before. And again, Z is not going to be accessible directly by fire truck. Instead, we'd have to interact with it through the public or protected member functions that we've inherited from truck. So just to run through this again, truck's on the left, fire truck using protected mode of inheritance on the right. X becomes protected, Y stays protected. So notice here, we no longer have the ability to write ft.x is going to be a compilation error because again, at this point, X is protected and no longer accessible to the outside world. And we'll see we're shifting away from an is a relationship and to an implemented terms of relationship. So private, I guess I spent a bit more time on protected than I wanted, but let's just run through private here and we'll see many of the same ideas are going to be kind of maintained. So private inheritance is going to be typically used to express and implemented in terms of relationship. Notice we're getting away from this idea of an is a relationship where we kind of inherited and could use all of the behaviors of, say, the base class both in and outside the scope of the class. Here, everything's going to be restricted to within the scope of the class. So this visibility is going to be used when we would like to use the base class's public interface in the derived class. So if we inherited from, say, a standard library vector using the private mode of inheritance, we could use things like pushback within our definition of, say, our fire truck functionality. However, users of our class would not have access to the functions that we inherited because, again, they're only going to be accessible within the scope of the child class in this case. So the visibility, again, it's used when we're looking to use the base class's public interface in our derived class's behaviors, but are restricting it so that the user cannot interact with those behaviors directly. So what this means is all the public stuff in the base class is now going to be private within the derived class. Likewise, Y is also going to become private. And notice that if we were to have like a, I don't know, class baby fire truck inherit from fire truck, we wouldn't have direct access to these because, again, this is private and it's not going to be accessible to any derived classes. Z, again, here, it's same as before. We can't interact with it directly because, well, Z is private to the base class. So to interact with that, we'd have to go through the public or protected member functions that have been afforded to us by truck. So here again, we're just setting this up, class truck on the left, fire truck on the right, using private inheritance. We can see that the data member X is going to be private to fire truck, Y is going to be private as well, and then Z is not going to be accessible from fire truck because it was private within the definition of truck. So just running through this visibility of inheritance in our trucks, which visibility of inheritance is most appropriate for our truck inheritance scheme? Well, we would like to express an is a relationship. So in this case, public is going to be most appropriate because a fire truck is a truck, a cement truck is a truck as well. So let's go ahead and move on to a conceptual inheritance walkthrough, and then we'll conclude with some additional material through an example, again, using our trucks.